So we're gonna have to think back to that law of conservation of mass. I know you guys, we did that ed puzzle on it way back at the beginning of the semester. I think it was on day 2 of the semester. So we're gonna think back to that law of conservation of mass and the fact that it tells us the amount of matter or mass is neither created or destroyed during any physical or chemical change. So when we rip things, we change the shape, we actually make a chemical reaction happen. Nothing is going to change in terms of the amount of matter that exists. So therefore, the mass has to stay the same before and after a chemical equation, which is why we have to balance these chemical equations. So our chemical equations demonstrate this principle because they're always balanced, which means that the total mass of the reactants must equal the total mass of the products. You can check to see if an equation is balanced by counting up the number of atoms it has on the number of atoms, and it has to be the same on both sides. So if we look at this equation below, we can see that it tells us that you can have 2 nitrogens and 6 fluorines on the left side, and you have 2 nitrogens and 6 fluorines on the right side. So the reactants and the product side, because if we remember from our types of reaction gizmo, the reactant side, because I'm going to use those terms, so I'm going to rewrite it. Reactants are the left side of our equation, and then this is a yield sign or a make. Yield or make, that's what the arrow stands for. And then other side are our products. So you have our reactants, yield, our products. To balance an equation, you can adjust the coefficients until they're the same number on each side, but you're never allowed to change the small numbers, those subscripts. So you can never just make this a 6. You can't just make that 6. You can't change those numbers below. This cannot happen. It has to stay a 2. So you can't change the chemicals you have. You can change the amount that are present during that reaction, though. So we're going to go through a couple of these together just to have some background knowledge about it. And then I'm going to let you guys work on this on your own. You also do have a formative today. It's a quicker one. It's just identifying types of reactions, but you also need to be able to explain them. So for this first one, so it says what we need to do is we need to balance each equation by using the law of conservation of mass. There is a chart above each problem to help you. Use the chart to make sure you have the same number on each side for each atom. So it gives us our steps. And our first step is to count the number of atoms you currently have. We're gonna write that number in the box. So can anybody tell me on this reactant side, how many hydrogens do we have right now?
2.
We have 2, perfect, because that subscript tells us there are 2 of them present. And how many oxygens do we have?
2.
2, perfect. We have to do the same thing with our product side. So now our products, how many hydrogens do we have?
2.
And we have 2. And how many oxygens do we have?
1.
We just have the 1. All right, so I know it says do it in pencil because if we had paper, doing it in pencil would be perfect. We don't have paper, so doing it on your iPad, you should be able to erase things if need be and change things if need be. So that part we can ignore. But the second thing it says is if the numbers don't match, try adjusting those coefficients one at a time to make the change in those numbers to match up in the chart. So we're going to look, do our hydrogens, do they match right now?
Yes.
They do. So I'm going to put a check mark in there for now, just so I remember. Do my oxygens match?
No.
No, they don't match, which means we have to fix something. So if we go in, we're trying to fix something. Which side has less?
Products.
The product side. So the right side of our reaction has less oxygens. In order to change the amount of oxygens, we can't put any numbers down here, because that would change our chemical formula. If we tried to put a 2 there, it would be hydrogen peroxide, which is a very different thing than water. So we can't change this at all, but we can change the number in front. When we put a number in front here, this is going to multiply into this whole thing. So multiply in. So if we put a number in front, it's going to multiply to everything in, just like if you have like in math class, if you had a 2 times like x plus 1, it would distribute into both of these things. If we put our 2 here, it's going to distribute into both the hydrogen and the oxygen. So it's going to go into both of those things. So now we have twice as much of each of them. So we're going to change this. So instead of 2, how many hydrogens do we have?
4.
We have 4 because we have twice as many. So we have 4 hydrogens, and instead of 1, how many do we have?
2.
We have 2. Perfect. Now let's double check. Do my oxygens match?
Yes.
Perfect. So now we're done, right?
No,
No, why not?
because your hydrogens don't match.
Because I messed up the hydrogens. Does that mean I did something wrong? Do we think I did something wrong? Do you just have to start over? What do we think? Is this wrong right here?
You just need more hydrogens.
We just have to add more to the other side. Perfect. So we're going to add another one to this side because this is not right anymore. So we can get rid of that check mark. But on the right side, now how many more sets of hydrogen do we need on the reactant side, that left side?
One more.
We need to add a second one. So we're going to have 2 sets of hydrogen now. And so now this number changes to how many hydrogen add?
4.
4. Wonderful. Now do my hydrogens still match? Or
Yes.
they match. Do my oxygens still match?
Yes.
Perfect. So now we have a balanced chemical equation. The one thing I do want to just make sure you're aware is this right here. If it's blank, the other way we can write it if it's blank is we can put a 1 in there. If you think it's going to be more helpful to you for you to remember that that means 1, if there is actually a 1 there, go ahead and put that there. Otherwise, if you leave it blank, I'll know that it's a 1 or that there's only 1 present, because if we don't have the 1, we can still see that there is an oxygen there. It's not like it's going away because the 1 doesn't exist. Any questions on this? All right, then I want you guys to go ahead and take about 2 minutes to try the next one on your own. Try and balance that equation, then we'll go through it together. All right, can anybody tell me how many phosphorus we start with on our reactant side?
4.
Start with 4, awesome. How many oxygen do we start with?
2.
2, perfect. All right, on our product side, how many phosphorus do we start with?
2.
2, and how many oxygens do we start with?
3.
3, awesome. Everything matches, right?
No.
No, all right, so what's the first thing you guys did?
I added like another set of the product to make the phosphorus match.
Perfect, so now we have 2 instead of 1, so 2, when that 2 distributes into both the phosphorus and the oxygen, which means how many phosphorus do you have?
4.
4, awesome. How many oxygens do you have?
6.
6, awesome. All right, so our phosphorus match. Our oxygens, do they match?
No.
No, so how do we make our oxygens match?
Putting 3 more oxygens from the reactants.
Perfect, we need 3 sets of oxygen, so that 3 goes into our oxygen, making it how many oxygens?
6.
6, and now do our oxygens match?
Yes.
Perfect, did we change phosphorus at all? Did we mess it up?
No.
Nope, so we are done, we're balanced. We need 1 P4 and plus 3 O2s, make 2 P2O3s. How are we doing on this? Does it make sense what we're doing?
Yeah.
Perfect, all right. So it looks like there are 10 more. And then you also have your answers already there. So if you are really struggling, you don't understand what's going on, the answers are there at the end for you to look at. But I really recommend, because this is our introduction, this is to get us going. Like we are going to be doing balancing a ton throughout the rest of the semester. So I really recommend you try to do it on your own before you go ahead and look at the answers. I would try and get through all the problems, but if you need to look at the answers after each one, whatever works best for you. And then whenever you're finished with it, you can turn it in. The other thing that we are doing today is a formative on types of reactions. So on Canvas, you should find a formative through the Canvas quizzes, and that formative is going to have your types of reaction formative or formative 5.2, I believe is what it's called, for you to work on.